This video is on creating a scatterplot graph. To create a graph in Excel, you will need two columns of values. One column will be your independent variable, or the values that cause the changes seen in the other column of the dependent variable. In this example, we are going to graph ice cream sales over 12 days at different temperatures. We will check to see if there is a correlation between these two variables. In this case, the temperature will be our independent variable, since the temperature on a certain day will not be influenced by the amount of ice cream sold on that day. The ice cream sales will be our dependent variable, since it might be influenced by the temperature on that day. The first step in building a graph is to use the tools from previous examples to format your data, such as the cut, copy, and paste functions. You will want your data in two columns, with the independent variable on the left column and the dependent variable in the right column. This will place the independent variable along the x-axis on the bottom of your graph, and the dependent variable along the y-axis or vertical axis, which is usually along the left side, but not always. Once your data is in the proper configuration, you can click on the Insert tab at the top and choose your chart type from the icons. For this data set, we will be making a scatter plot and choosing the type without lines. At first, the chart area is empty because no data has been assigned. We click on Select Data, and a dialog box will open with the cursor in the Chart Data Range box. While the cursor is in this box, we can click and drag to select both columns of data, including the headings. The chart area will populate with the points that correspond to the intersection of the two values, one for each column. Scrolling over the points will give you the two values, one x and one y, that create that point. So, on a day with 14.2 degrees Celsius temperature, $215 in ice cream was sold. Let's say you also wanted to check the correlation between the temperature and popsicle sales on the same days. You would simply enter the data for the popsicle sales in another column and add it to the chart data range by clicking on the Select Data button and clicking the Add button under the Legend Entries heading. Another dialog box will appear asking for the information from the new series. The series name is in cell C2. The X values will again be the temperatures A3 through A14, since they didn't change. And the Y values are the new column with the popsicle sales, C3 through C14. From simply looking at these sets of data for both ice cream sales and popsicle sales, there appears to be a trend in which the sales for both increase as the temperature increases. This trend will be further evaluated with our t-tests performed later on. You can also see that the data seems to be fairly linear. The next component we will add is a trend line, which will tell us just how linear this data set is and how much of the data actually fits on the line. If you select the chart area by clicking on it, the Chart Tools tab will appear. We are going to select Layout and click on the Trend Line button. We will add a linear trend line based on the first data set for the ice cream sales and then again for the popsicle sales. If we click on the Trend Line button again and select More Trend Line Options, we can display the equation for the slope of the line on the chart and the r-squared value as well. This will give us a measure of how much the temperature influenced the sales of ice cream or popsicles on a given day. The r-squared values can range from 0 to 1, with 0 being no correlation and 1 having all of the points fall perfectly in line. The slope of the line tells you how much of an increase in ice cream or popsicle sales you are seeing for each unit of increase in temperature on average. This rate can be expressed as dollars in sales per degrees Celsius.